You know, there's a piece of technology that's pretty much running the entire world behind the scenes. I'm talking about everything from your bank account to your Instagram feed. That technology is SQL. It's the language we use to talk to our data. And its story, well, it's one of the most important stories in all of modern computing.
So let's just start with a really big question. Think about it. We are creating these just mountains of information every single day. How in the world do we keep all of that from turning into total chaos? How do you find exactly what you're looking for instantly? Well, that fundamental problem, that's exactly what SQL was built to solve.
Okay, so before we can even begin to answer that, we have to talk about the kind of information we're dealing with. It really all boils down to one simple but super important idea: structure.
So what is structured data? The best way to think about it is like a perfectly organized library. Seriously. Every single book has its place on a specific shelf. Every author has a card in that old school catalog. And you know precisely how to find what you're looking for. Everything has a defined spot and a clear connection to everything else. That is the world where SQL lives and breathes.
Right, so we've got this amazing digital library, all neat and tidy. But how do you ask it questions? You need a language, right? A common tongue that anyone or any computer program could use to pull out information. And that language, you guessed it, became SQL.
And the crazy thing is how fast this all happened. I mean, look at this timeline. It starts out in the 70s as a research project at IBM. The whole idea was inspired by this guy, Edgar Cod, and his relational model. Now that sounds super technical, but it's really just a genius idea. Organize all your data into simple tables, kind of like spreadsheets, and then define how those tables relate to each other. Simple, right? Well, by 1979, the first commercial version was out, from a company that would become the giant Oracle. And just a few years later, bam, 1986, it's an official standard. And get this isn't some dusty old tech, it's constantly evolving. The last major update was just in 2023. It's very much alive and kicking.
So, let's get down to brass tacks. What is SQL really? It stands for Structured Query Language, and it's what we call a domain-specific language. All that means is that it is laser-focused on doing one thing, and one thing only: managing data inside a relational database. You know, that digital library we talked about? You're not going to build a website with it. You're not going to make a video game with it. Its entire purpose in life is to talk to data.
And this is why it was such a total game changer. See, before SQL, if you were a programmer, you had to write all this complicated code that spelled out step by step how to go find a piece of data. It was tedious. SQL flipped that script completely. With SQL, you just tell the database what you want. That's it. You say, give me all the users from California, and the database itself figures out the how. It was a huge leap forward in making data accessible.
Okay, so you'd think, great, there's an official standard, so every SQL is the same, right? Well, not exactly. This is where the story gets a little messy. The truth is, there isn't just one single SQL. It's more like there are a bunch of different dialects. And there are some pretty solid reasons why this happened. For one, the official SQL standard is just huge. It's massive and really complex, so most companies just don't bother implementing every single part of it. Plus, they have to make sure their new stuff still works with their old stuff. Backward compatibility is a big deal. And let's be honest, there's not much reason for Oracle to make it super easy for you to pack up your data and move it over to a competitor like Microsoft. That's called vendor lock-in. So you end up with these small, but sometimes really annoying differences in how they handle basic things like dates or even just empty values.
But here's the thing. The story of SQL isn't just about the language. Not at all. There's a whole universe of tools and software that has sprouted up around it, creating this incredibly powerful ecosystem.
So at the very center of this universe, you have the engines themselves, the actual databases. These are the big names you've probably heard of. If we stick with our library analogy, these aren't the books. These are the buildings. They're the software that actually stores, organizes, and most importantly, protects all that data. The reason these things are trusted with our most critical information, we're talking financial records, healthcare data, is because they are just unbelievably reliable.
Now, how do you actually work with one of these powerful engines? Well, for that, you use a management tool. Think of it like the librarian's command center or the cockpit of an airplane. It's the interface that lets developers write their SQL queries, manage who gets access to what, and generally just make sure the whole system is running smoothly.
Then you've got these really clever tools called ORMs. That stands for Object Relational Mapper, which is a mouthful, but the concept is simple. They're translators. Imagine you're a developer who loves writing in Python. Instead of having to stop and write a bunch of SQL, you can just write Python code to talk to the database.
The ORM works in the background, translating your Python into the right SQL automatically. It's a massive time saver and lets developers just stay in the zone, using the language they know best. And last but not least, we have the storytellers. These are the business intelligence or BI tools. Think Tableau, Power BI. They plug right into those SQL databases. If the database is the library, these tools are like magic reading glasses. They let you instantly visualize all that data, spot trends, and uncover amazing insights that would be totally buried if you were just staring at millions of rows in a spreadsheet.
Okay, so SQL has been king for 50 years. But then the internet explodes, right? Big data comes along and suddenly we have all this messy, unstructured data. Think social media feeds, sensor data from your phone, and a whole new category of databases called NoSQL popped up to handle it. For a minute there, a lot of people were asking, is this the end for SQL? So why is it still so dominant even now?
You know, this quote from Wikipedia really nails it. SQL isn't perfect. From a pure computer science theory perspective, it's got its quirks. But here's the thing. It just works. It was good enough, it was powerful enough, and maybe most importantly, it was simple enough that it just took over the world. It became the undisputed champ.
And really, it all comes back to that one core idea we talked about earlier. The absolute genius of SQL is its simplicity. That declarative nature, where you just say what you want, not how to get it. That's its superpower. It removes all the underlying complexity. And that's what made it so incredibly reliable for the kind of data that just has to be right. And it's what allowed that entire universe of amazing tools to be built on top of it.
So that just leaves us with one last question to chew on. For half a century, SQL has been the bedrock, the absolute foundation for how we manage organized information. It survived tectonic shifts in technology. So you have to wonder, what's next? After 5 decades of total dominance, what could possibly come along and replace SQL?